Software as a service has been a big change to how data is accessed across the enterprise WAN today. Applications that used to live in the data center now live out on the internet. In this case, we have Office 365. And I'm accessing those applications traditionally through what's called a backhaul, where my users in my branch office have to go all the way back to my data center to get out to internet and then out to the application. And this creates big performance issues. If we look at our network here, we have our San Francisco data center. I've got a local internet connection and an MPLS connection. My local internet is 10 gigabits per second, so it's really fast. And it only takes me 10 milliseconds to get to Office 365, so it's relatively close. If we look at my Atlanta branch office, they only have connectivity through MPLS. And because the internet is only accessible out of San Francisco, they have to traverse the entire country to get back and get out to Office 365 in this case. And this takes 70 milliseconds to get just to San Francisco, an additional 10 to get out to Office 365. And so if we look at the life of a packet as it leaves from Atlanta, they're going to have to go all the way through the MPLS network. They go out to internet from the data center and then out to Microsoft. They service the request, and then the reply happens. And then we repeat that process all over again. And essentially, this takes 160 milliseconds to get there and back. And the other problem I have is I have a limited finite amount of bandwidth. I only have 10 megabits per second in the branch. And so if I have a lot of users out there, they don't have a lot of bandwidth to work with. In fact, most users have more bandwidth in their home network. So how does SD-WAN help solve this problem? So SD-WAN allows you to look at introducing broadband internet into the branch. And so if we just start by adding on an EdgeConnect appliance here, that EdgeConnect appliance can terminate the MPLS circuit and provide connectivity back to your traditional network and data center, but it also can leverage local internet access. And so in this case here, we'll go ahead and we'll add in a broadband internet link into this branch and connect that up to the EdgeConnect. And the EdgeConnect has a built-in stateful firewall, so it can secure this connection, make sure that any traffic coming in or out of it is inspected. What it also can do, though, using our business intent overlays, which allow you to define how traffic routes based off the application, and using First Packet IQ, our application recognition engine that can identify millions of packets or millions of applications off the first packet. When my users in Atlanta go out to Office 365, I can execute a policy across my entire network, and I can tell all of my branches, and in this case it would be Atlanta, that if they're trying to access Office 365, they need to go direct to net. They need to go right out. And so rather than going all the way across the country to get to Office 365, what we would do here is we have Office 365 who actually maintains a global network that is very fast and all over the place. And I would actually have this policy on the EdgeConnect. The packets arrive to the appliance. We identify them with our application recognition engine, and we can identify essentially any internet-based application. And we would send them direct to net. And they go out at a really high rate of speed. Let's say they have a 100 meg internet connection here, and a really low amount of latency, maybe 10 milliseconds. And so I send that request out. It happens a lot faster, and my latency is much lower to the application. And my reply comes back here, and it's only 20 milliseconds now to get out to Office 365. And so the user already has 10 times the bandwidth and a fraction of the distance in routing to get to the SaaS-based service. It's going to work a whole lot better. If they need even better performance and better security, what they can do is they can actually spin up EdgeConnect in Microsoft Azure, for instance, or Amazon, and we'll just call it Azure on this one. And they can connect the EdgeConnect from the local branch into the EdgeConnect. And what they can do is they can actually encrypt this connection so that all packets traversing the internet that are destined to, in this case, Office 365, get encrypted into Microsoft's Azure cloud. And then Azure has a local backbone that peers with Office 365. And let's just call this as 1 millisecond in hundreds of gigabits per second. I'm optimizing the traffic to the doorstep. I'm identifying the packet that needs to go encrypted into Azure, and I have really good performance because it's almost like I'm local now. I'm accelerating the connection all the way. For other applications, let's go ahead and add Salesforce in the mix here. And what we're also going to do here is we're going to introduce a EdgeConnect appliance into the San Francisco data center. And so for Salesforce, who also operates a global network, my users in San Francisco and my users in Atlanta may be accessing different sets of IP addresses. We can actually measure from each location what's the best way to get to Salesforce. Should I go across the network or should I go local internet breakout? And for what IPs or what destinations should I do that for? And so in this case, what we'll see here is that the EdgeConnect in San Francisco knows about all the different Salesforce subnets, and so does this EdgeConnect appliance in Atlanta. And so for subnets that are in Atlanta, he's going to maybe measure, or close to Atlanta, maybe 10, maybe 20 milliseconds of latency. And for subnets that are maybe closer to San Francisco, maybe he measures 5 or 10. And then when a user goes to access this, this new service, Salesforce here, he's actually able to look in our SaaS application engine, and he's able to identify which subnets are closest to him, which are closest to his doorstep, and he will send that traffic directly out to Salesforce. If there's a better route across the network, EdgeConnect can actually accelerate to another site and then direct out to the net if those subnets being advertised are of a lower cost. And so this allows me to actually have not only local breakout, but potentially an optimized platform for getting to the best possible location for a SaaS-based service.